Welcome to my YouTube channel. Today, in continuous series, we will start with the rule number 4 to find integrating factor to solve the differential equations. As we have done three methods already, now we will go with the fourth method to find integrating factor and solve the equations. So, if we have equation like mdx plus ndy equals to 0, and again the same thing over here, your equation is not exact. It means that del m by del y is not equal to del n by del x. In that case, we are finding integrating factor. As we have already done our three methods to find integrating factors, now there is a fourth method. In this case, if your del n by del x minus del m by del y divided by m, if this is a function of y only, then your integrating factor would be e. F of y dy will be your integrating factor. Now, to elaborate this and to get a better knowledge of this, we will come with a question. So, suppose that the equation is given as like y raised to power 4 plus 2y dy, sorry, here is a dx, so here should be a dx, then xy cube 2y4 minus yx dy equal to 0. Now, as we can see that here the previous methods are not applicable because it is not a homogeneous and it is also not a second type equation. So firstly, we will check that what is this function is exact or not. The value of m is y raised to power 4 2y. The value of n is xy cube plus 2y4 minus 4x. So in this case, we have to find del m by del y and we have to find del n by del x. So here del by del y raised to power 4 plus 2y. Again, we will find derivative by parts. So here in this case, derivative by parts. So it is 4y cube plus 2. So similarly, if we want to find it, here we will get xy cube 2y4 minus 4x. Again, here should be a differentiability by parts. So here is differentiability. So again, if I am taking partial derivative with respect to x, it means that y is treated here as a constant. And here we will get y cube del x over del x plus, again, we are finding partial derivative with respect to x. Here is a y treated as a constant, so it should be 0 minus del by del x over x. So if we will solve it, here is y cube minus 4. So here we can see here del m by del y is not equal to del n by del x. It means that equation is not exact. Now, as we know, if our equation is not exact, what we have to do? We have to find integrating factor. Now, we will find integrating factor here by using del n by del x minus del m by del y divided by m. As I already told you, this is not a homogeneous equation and this is not a second type equation, so you are not able to apply here the method. On the other hand, if we will go with the third rule, according to third rule, we have del m by del y minus del n by del x divided by n. So if we will go with it, it is 4y cube plus 2 minus y cube minus 4 divided by xy cube plus 2y4 minus 4x. So here is a 4y cube plus 2 minus y cube plus 4 divided by xy cube plus 2y4 minus 4x. So here is 3y cube plus 6 xy cube plus 2y4 minus 4x. As you can see, here it does not remain the function of x only. Here it comes a y also. So we are also not able to use this integrating factor. So we will come with the next integrating factor. So in this case, again, your del n by del x is y cube minus 4, and our del m by del y is 4y cube plus 2. So it is a 4y cube plus 2, and the value of m is here y raised to power 4 plus 2y. So it is y cube minus 4 minus 4y cube minus 2 y4 plus 2y. So here it should be a minus 3y cube minus 6 y4 plus 2y. Negative is common, 3 is common, y cube plus 2. Y is common, y cube plus 2. So minus 3 by y. Now you can see that this is a function of y only. So in this case, its integrating factor is e f of y dy. It means e minus 3y dy. So 3 is a constant, 1 by y dy. So e minus 3, it here is a log y. As we know that a log b can be log b raised to power a. So here it should be e log y minus cube. Then you will get y minus cube, that is 1 by y. So this is our integrating factor. After finding integrating factor, what we have to do, we will multiply this integrating factor with our equation. So what will be the equation is, it should be a y4 plus 2y dx plus xy cube plus 2y4 then minus 4x dy is equal to 0. So if I will multiply this with my integrating factor, which is a 1 over y cube, so here 1 over y cube y4 2y dx 1 over y cube xy cube 2y4 minus 4x dy is equal to 0. So if I will divide it, I will get y4 by y cube 2y by y cube dx plus xy cube divided by y cube 2y4 divided by y cube 4xy cube dy is equal to 0. So here we will get y plus 2 by y square dx plus, here it is x, here it should be a 2y minus 4x divided by y cube dy is equal to 0. Now the resultant value should be exact. We can solve this differential equation by using our simple method, that is mdx, where y is treated as a constant, plus here is a terms not containing x in n equal to c. So have a look. Here is a y plus 2y square dx. Y should be a constant term plus term not containing x. This term contain x here. This term contain x here. We will left only with one term, that is a 2y. So here should be a integration of 2y dy equals to c. So again, integrating by parts, y dx plus 2 by y square dx plus 2y dy is equals to c. Again y is constant, y is constant. So y comes outside, integration over 1. 2 over y square is constant, integration over 1. 2 is constant, y dy is equals to c. So here it should be a x. 2y square integration of 1 dx is again x plus 2 by y square by 2, because integration of y dy is y square by 2, that is a c. So we will get xy 2x by y square plus y square is equals to c. So this is the required solution of our differential equation. If I just want to go back and tell you what is actually in this method. So in this method what we will do, we will see here another method to find integrating factor. After finding integrating factor, we will multiply the value with our differential equation, and then we will solve our differential equation with the simple method that mdx, y is the constant, terms not containing x in n dy is equals to c. So the same thing we have done, we're taking an example where we will see that the equation is not exact, because in this case it has different values. So again we will see why it is not able to use rule number 1, because it is not a homogeneous, why it is not rule number 2, because it is not a differential equation of second type, why rule number 3 is not applicable over here. Then we will go for rule number 4. In this case, we will find its integrating factor. After finding it, we will multiply this integrating factor with our differential equation, and we will solve this differential equation by using our previous method. So thank you very much.